Hello folks, how's everybody doing? I'm fortunately doing fine. Had an operation on Thursday and my left leg, they killed one of my veins, just a superficial vein, and I came out of it all right. There's always a danger because they put you to sleep, and whenever they put you to sleep, it's a respectable situation. Anyways, hopefully I'll have better defenses next time I get a bacteria like I had September, October. Anyways, I want to remind people that we have a conference coming up in Lusaka. That's in Zambia, country in Africa. So if you want to have a good adventure, want to get to know Africa, if you've never been there, well, here's your chance. You'll be meeting some great people. Okay? So recommend that people, they plan to attend, they can attend, make reservations in advance, okay? Okay, I want to start with some questions today that I received. I received lots of questions, can't answer them all, no way. And all I can do is remind people that, this site has a different notion of what science is. Okay, that's why it's called rational science. We're a little different than mainstream science and just about, in fact, all other dissident sites. Okay, yeah, we are dissidents. We disagree with the mainstream, with the official versions coming out of mathematical physics. We don't agree with their version of science. Okay, so we have a different notion of what science is, and a lot of people, they have this impulsive commenting. They come in and impulsively they say, "Oh, I'm going to answer that issue that he raised there," and they don't bother to take, the time to investigate what this channel is about, and they come in here, and again, it's like impulsive commenting without understanding. And so, I want to kind of summarize real quickly what this site is about, okay, and why we're different than the mainstream and the dissidents out there. Okay, we're totally different than all these people. And you might say, well, everybody says that. No, we are different. You'll see in a second here, okay? And here it is. This is a list of what we consider not to be science, okay? And, if you went to high school or college, you probably learned something different. You'll be shocked by what we say is not part of science. We consider it, most of these things, as part of religion, not science. And so get ready if... hold on to your seat. If you've been educated to believe these things are part of science, we're saying that they're not. None of them. Okay, here it goes. Okay, none of these are part of science. Okay, we don't use evidence in science. We have no use for evidence whatsoever. We don't prove. We don't talk about truth. We don't talk about fact. We consider all those opinions. Okay, we don't use equations, math, or calculate. None of that has anything to do with science. We do not use numbers. We do not use variables, manifolds, mathematical objects. We have no use for none of that stuff that mathematical physics uses. Okay? I'm just reading a comment there. Anyways, we don't use math. Math has nothing to do with science. Math is not the language of physics. Math has absolutely nothing to do with anything. Math is a language, and as a language, it can only describe. What it describes is quantitatively, and we have no use for it because of the definition of science. Science, rational explanations. You have to explain a mechanism as it pertains to physics, right? You have to explain a mechanism. And we have no use for mathematics to explain a mechanism, okay? So if you've been drilled to exhaustion, if you've been conditioned, quotations there, to believe that mathematics is part of science and we can't do without mathematics, here we wipe it all out, throw all the math books in the world in the trash can, and erase all equations. We have no use whatsoever for them. Math can only describe. Science, as it pertains to physics, needs to explain. You need to explain a mechanism, you have to do it rationally. That's what this site is about, okay? It's got to be rational. What is rational? Specifically, there's several criteria, but the main one, we can't move a concept, okay? If you're moving concepts around, you're moving love around. You know, if you juggle intelligence, if you transmit information, then you're a religious fanatic. You have nothing to do with science, okay? So we do not use the words energy. We do not use four-letter words such as mass or force or time. No four-letter words allowed here, okay? We don't use concepts. We do not move force. We do not move time. We do not bend time. We do not do anything with mass. None of that has anything to do with physical interpretations of a mechanism. Okay, so you need to understand that before you put comments, okay? We do not do any measurements. We do not do experiments. Science has nothing to do with experiments. In science, we do not do experiments. In science, we explain them, okay? So we do not do experiments. We do not verify anything. We just create a theory that explains what happened, okay? That's physics. That's science, okay? No observers, no testimony. We don't do observations. People say, what do you mean you don't do observations? How can you even start if you haven't observed a phenomenon? And so sometimes I need to answer that question because, people are truly mistaken in the context, okay? They truly have a problem understanding the context of what I mean when I say that we do not observe. Has any of you observed the creation of the universe? Okay, has any of you ever observed the creation of the earth or the sun? That means those things are out. Has anyone observed evolution happening? Are those not topics of science? Are we not going to deal with them because we have not observed them? If something happens on the other side of the universe, which we can't hear, see, touch, blah, 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 smell, it's not a part of science. We cannot deal with that. What we do in science, we make an assumption, okay? You go to the blind man, the blind sage. He cannot be a scientist because he hasn't observed. So what we do is we ask him, look, I give you a hypothetical question. Say, dear sage, dear blind sage, imagine another world on the other side of the universe, and this thing happens over there. Can you explain it? Can you tell us what the mechanism would be for such an event? And the sage says, okay, come back tomorrow, let me think about it. So he thinks about it. He hasn't observed anything. It's a hypothetical situation. And he says, look, this is the answer I give you. This is the mechanism I propose for that event. I mean, did Stephen Hawking ever observe a black hole? He's famous for black holes, right? Hopefully he never observed a black hole. He probably never even looked through a telescope. Maybe he did sometime in his life, I don't know. But, you don't have to observe anything. You just have to hypothesize and put the assumptions down, and over those assumptions, build your theory. We're interested in the mechanism, in the theory, okay? That's why observation has nothing to do with science. We don't gawk in science. We explain. That's why observation is not part of science, okay? Now, knowing knowledge. We have no use for knowledge in science. And I'll get to that in a minute. Okay, I'll cover that because there was another comment. We don't collect data, and we don't describe or just describe a chair. That's science. We say, yeah, a chair has 4 legs, a seat, and a backrest, and maybe 2 armchairs, 2 place to put the arms. So the issue here is that you know, a lot of these issues that people bring up, like description and so on, they have nothing to do with science. Science is not about just describing that the sky is blue. Science is trying to explain something. Why is it blue? What's the cause that it's blue? Okay, so those are the typical contexts. Okay. The other thing is, again, you know, we don't use the senses, any of the 5 senses. There's only one sense, and that's the sense of touch. Every one of those senses relies on touch, including sight, but that's a long story. It's under the rope model that the sense of sight is touch. Okay, it's a long story. Won't touch it today for sure. We use that other thing called the brain. Okay, that's what we use. You got to think, you got to reason. You got to make sense of a mechanism and be able to tell it to someone. That's it. Okay? So that's science as far as we're concerned in this site. You know, a lot of these mathematicians, as we call them, they have this situation where they say, look, here's a black hole, okay? And it goes around and around, the star goes around and around the black hole, okay? And they say, well, what is a black hole? Well, it's a mass, a big mass, an enormous mass, a runaway mass that's over there in the center, and a star just goes around it, okay? And we're not interested in that because mass cannot, you can't see the mechanism there. You stare at that, and the question is, what is the mechanism? You know, what are we staring at? We're just seeing a star go around nothing. In this case, there's something, but when they look at the night sky, they never see a something. They just see darkness, and they see a star going around, okay? And the question is, you know, can we just say and give you a mechanism to say mass does that? It's a runaway mass. That's why that star is going around nothing. Well, by saying mass, we have not figured out what the mechanism is. You know, the question is, what binds that star? What's in between the star and the black hole? That's what we want to understand. Unless you can tell me what physical object lies between the so-called black hole and that star that's going around, orbiting around a center of mass, we have no mechanism. And that's the issue. The issue is we need to figure out mechanisms in physics. Okay? So that's what this site is about. Okay? We need to do things with objects. The language of physics is illustration. Okay? You need to illustrate. You need to make a movie of your mechanism in order for us to follow your reasoning of how Mother Nature could be doing her, especially her invisible stuff out there. How does she do light? How does she do gravity? How does she do magnetism, electricity, the workings of the atom? Those are the things we want to see, and we want to see it in a movie. And for that, you need to put objects. You can't put energy in there. You can't put mass. You can't put force. You can't put time. We have no use for those words because those are concepts. We can't say time did this and you know, energy did that. That's not a physical interpretation, and that's what we're looking at. Mathematicians dismiss that as philosophy. They say, well, that's philosophy. We don't deal with that. Yeah, they don't deal with it because they can't explain how this universe works. But then they come into the qualitative world and they purport to explain how this universe works, and they say they inferred that or derived that, or, you know, through experiment and through math. And that's how they come up with this nonsense as like black hole, dark matter, Big Bang, and all this other nonsense they came up with in the last few years. So they do cross over into the qualitative world. And when you say, look, what you just told me is irrational, they say, well, that's philosophy anyways. What's important is math. And you can see that in all their papers. If you go to the literature, what you'll find is a lot of math, a lot of equations. You'll never find a picture. You won't find a mechanism of how Mother Nature does her, runs her shop, how Father Nature runs his universe. Okay? Father Universe runs his universe. Okay? So this is the issue. Here we're interested in mechanisms. We're interested in how the universe works. That's what we want to get to. We figured out all the visible stuff. You know, we know how seesaw works. We know how the window broke. You know, brick went through the window. We know these things. We can see everything. What we cannot see is the magnet. What's between two magnets? What we cannot see is gravity. We let go of the pen and the pen falls to the floor. We cannot see what did it. That's science. That's where you have to break your head. And there's only one way to do that, and that's try to visualize what medium, what mediator is in that space. And for those who say, well, there's nothing there simply because you can't see it or touch it, well, those are deluded individuals because they're essentially doing it with spirits and black magic. There is something that you can't see and you can't touch in that space. We just need to make it visible on the screen. That's how we're going to explain the mechanisms in this site. Okay? Okay, anyways, another comment. This fellow talks about knowledge. Again, we have no use for knowledge. If he would have looked into this area, he would have saved himself the trouble of writing a long comment. I just took portions of it here. Your notions of knowledge and predictions are confused. Oh, okay. You can't know something in advance because it implies that it has already happened. Okay, I know that. Okay. The future has, per definition, not happened yet. Okay, that's what I said. What we say follow from causes are just hypotheses. We form from having observed correlations very many times. In other words, he says, if your girl, loves candies, you know that if you put some candies on the table, you know when she comes home from school, she's going to grab one of those candies, sneak it, steal it, eat it, whatever, right? Because you've seen it happen many times. You know, it's like a habit. That's not knowledge. That's it's called an intelligent guess. Okay, and that's what he's talking about here. We can't know the same thing will happen next time with absolute certainty. I said all of that as well, so I don't know what his comment was or what his objection was, how he said that I'm confused. That's exactly what I said, so I don't know maybe he saw it superficially, I don't know. But this is my answer just in case for those who wonder about the word knowledge. Knowledge, the ability to predict the outcome of a specific experiment without error. Well, we don't deal with predictions, and we don't deal with experiments, and we don't deal with knowledge in rational science. So we don't have to worry about that, but I'm just defining it so that so whenever we use the word knowledge, we know what we're talking about. Knowledge only deals with the future. Knowledge is the same thing as omniscience for a specific instance, for a specific event, for a specific experiment. So it means you know every aspect of it. You know exactly what's going to happen, and that's impossible. Okay, because you don't know if there's going to be an earthquake that prevents you from running your experiment. You don't know if an asteroid is going to hit the Earth and break it into a million pieces. You never get to do your experiment. So all you have is an intelligent guess. Okay, and today we have it defined, knowledge, we have it defined as justified true belief, which is Plato's definition. It's still in vogue. Okay, and that means knowledge is just belief. That's all it is officially. Okay, my definition is up there. If you don't like it, you don't like either of these definitions, you have only a single recourse, and that's to define the word knowledge. Okay, so if you don't like these definitions, very simple. You just have to come up with a definition of your own that fits your frame of mind, whatever. Okay, and regarding the issue came around because we have omniscience assigned not to us. We don't know. God is the guy who knows everything, or some people ascribe that, attribute that power to God. And they say God knows everything. Well, if God knows everything, if God is omniscient, okay, that means he knows the future. Because for him, the future has already happened, because he's outside of time, because he's just all-knowing, he's everywhere, he's every time. Okay, so it's a superpower we give to God. And the problem with that, if you say that God is omniscient, Whether he's outside of time, inside of time, in the 10th dimension, we don't care. None of that matters. If God knows exactly that I'm going to move my left hand next and my right hand after that, if he knows that, if he already knew that in advance, I have no free will. Okay? And I'm not going to deal with that anymore. Anyone who says the opposite is a deluded individual. There is no way to reconcile omniscience, knowing the future, with free will. No way. And they've been debating this issue for 2,000 years. Obviously, it takes a little more than just saying, oh, yeah, they're reconcilable. No. If they've been debating this issue for 2,000 years and haven't figured it out, you can go out there and do your own research. You'll find out lots of people debating this issue still. And a lot of people religious people, deluded individuals, trying to reconcile. No, God can know everything and I still have free will. No, if God knows exactly what I'm going to do next, if he knows what I'm thinking, I have no free will. It means the future has already happened. All I'm doing is walking on footsteps. And I can't deal with that anymore. It's just straightforward for any rational human being. And one of the things I use here is here. I showed it the other day. I'll show it one more time just to make sure. And as Felix, I made, I didn't make it, but I make a movie, okay? Does Felix have free will? Okay? He's an actor in a movie. And no matter what he does, he's got to do the same thing what I told him to do. And you might say, well, God doesn't tell us what to do. Fine. That's not the point. The point is here we have God in his filing cabinet up there in heaven, and he's got your file. He knows when you were born, and he knows already that you died, and he knows everything you did between. I mean, if he's omniscient, okay? Now, if he's just like us and doesn't know the future, it doesn't matter. But if God is omniscient and knows the future, he's got your file in that cabinet. Okay? And that means the future has already happened. If the future has already happened, you do not have free will. Just as simple as that. And if you can't understand that, well, go see a psychiatrist. That's all I can tell you. And here's another comment. And this one is related to vacuum of space. Love this one. Maxwell's electromagnetic theory defines the vacuum of space as a medium possessing at least two distinct physical properties: permittivity and permeability. This medium is the ether. So taking what he just wrote there, we define the ether as equal to vacuum of space plus two concepts, one permittivity and one permeability. That's what this individual is saying. Well, we have a little bit of a problem because this fella says vacuum is a medium. For this, we need to define what vacuum is and what a medium is. And it turns out that in rational science, rational individuals, not irrational people, but rational individuals realize that there's a difference between vacuum and objects and things and medium or media. Okay? Medium, here, let's define it just so we all are on the same page. Here it is. Okay, next, side by side so you can see it. Medium, that which has shape. Vacuum, that which doesn't have shape. Very straightforward. So vacuum is exactly the opposite of the word medium. Medium is the opposite of vacuum. They're antonyms. Okay? So when the person says vacuum is a medium, well, all we can do is ask him to define what a medium is, what he means by medium, by vacuum, and by space. That's just as simple as that. For us, it's very straightforward. Either it has shape or it doesn't. And if it has shape, we call it an object, thing, entity, medium. There's a lot of synonyms there: body, substance. And if it doesn't have shape, well, it's a concept. And one of those concepts is the word nothing, and that's what vacuum and space are. Space is absolutely nothing. Why? Because it's got no shape. There is no medium there. But all dissidents as well as mainstreamers, they all converted space into a physical object. Some into the ether, others into space-time. They have all this what they call vacuum energy, etc. in the background. Now, vacuum is nothing. Means it's got no shape, it's got no matter in it itself. If we take all the matter out of the universe and we have only space, space is nothing. There is nothing there. Okay? Space is exactly nothing. And it's very difficult for people to wrap their heads around it because we always talk in terms of objects, of media, of things. And here we're talking about nothing. Nothing. Nothing means the opposite of thing. Okay, another comment. And this fellow says, he looked at this picture and he says, the pic has Bohr saying he did not claim that particles in QM exist. I heard you said they cannot be visualized under any circumstances. Okay, did Bohr not back the existence of QM particles? Well, the issue is the word exist here. Okay, and the problem there is that Bohr never defined, or any of his disciples, any of his successors, defined the word exist. So we had to define this word because physics is the science of existence. And so you must define the word exist for the purposes of physics. Anyone talking about the existence of something has crossed the line into physics. And Bohr never did that. And so we don't know what he means when he says that a particle exists or doesn't exist. And that's the issue. Okay, once we define the word exist as object that has location, it's very simple. Either Bohr's particles have location or they don't. And that's up to him to determine whether it meets that specification, that criteria. Okay, so it's very straightforward. If something exists, it exists by definition, not because we believe. There's no provision for belief in the definition of exist. It just needs to meet the definition. God wants to exist, first he's got to be an object. He can't be a concept. He can't be love. He can't be intelligence. God's got to be an object. He's got to have some shape. And then he's got to have location. And if God does not have location, he does not exist by definition, not because we believe or stop believing or whatever. Okay? Any more than my chair disappears when I stop believing in it. Maybe I disappear, but not the chair. Okay? Okay, another comment, and this is related to particles, which comes to the subject matter we're going to have today. There are no particles. Tell that to, that's what I said, okay? There are no such things as particles. Tell that to all the cloud chambers over the past many decades. Tell that to the particle collision results at the Large Hadron Collider or other particle accelerators that rely on ballistic trajectories of the somethings that we call particles. The somethings, okay? If there is there really are no particles theory, it cannot be proven. Again, proof has nothing to do with science. Proof means you swallow the Kool-Aid. That's all proof means. Every time you mention the word proof, all you're saying you believe because you swallowed the Kool-Aid. You were hypnotized or whatever. You were conditioned somehow. Yet due to our lack of measuring devices, again, we don't measure anything in science, okay? It has nothing to do with it. This is a conceptual issue totally, 150%. You cannot see particles or fields that small. No observers in science. Again, all these failures to look at what this site is about. We don't use the eyes, we don't use the senses, we don't use the sense of touch in any way, shape, or form in science. We use the mind only. We have to visualize mentally, okay? Very hard for people to understand that because they think they got to go to the lab and run an experiment to do science. Not at all. The way you do science, you stay in your office, you grab a beer, okay? You sit back and you think, and you try to visualize, you try to explain how Mother Nature is running this universe. And if you cannot do it with particles, then you got to dismiss the particles, okay? And he continues to just wholesale say cloud chambers do not show paths of physical particles or the LHC is not colliding particles without physical evidence. Again, no evidence in science. I just don't think it's a reasonable position, okay? Because he's relying on the 19th century, really it's the 17th century method of science, the scientific method that came from us from the so-called scientific revolution of the 17th century. We have no use for that. It's called religion, okay? We don't use evidence, we don't use experiments, we don't use math. What we have to do is explain a mechanism of how Mother Nature is using her invisible objects to do gravity, light, electricity, magnetism, and so on, okay? Okay, and here's what they show usually what you see out there, and they say, see, those are particles. See, we've proven it. Well, have we? I mean, what you see there is supposedly, according to the people who do these experiments out there in the accelerators, what you're looking at there, supposedly, according to them, is an image of particles that have collided. And so what you're seeing there are traces. Let's get that right, okay? What you're staring at is supposedly an explosion of two particles in their bubble or gas chambers, right? And what you're looking at is traces. So what are we talking about here? We're saying that these people are saying that they can take a picture of a movie because those traces are verbs. And the particle is at the end of the trace. And you're saying, hold it, how did you take that picture? You took a snapshot of a trace of a particle going through the gas chamber, making this trace in what, a split second? Well, it turns out that these are not photographs. They're not pictures. They are reconstructions, and they're done electronically. They're done through algorithms and so on. So you're not staring at a photograph, but that's what they make you, or that's what people surmise. That's what they think they're staring at, you know. And the question is whether those are traces, those are itineraries, trajectories of particles, because you can still see the big explosion in the center, right? Well, you know, we have a different version of that same thing, and this is our atom, right? And it looks a lot like that without having any explosion or anything like that. If you have two of these atoms, the rope model of the atom, you have them collide, they would shake and they would look more or less like what these people are showing there. So the question is, are those little tiny particles, or are we just banging two atoms together that are made of, you know, threads and ropes? So, you know, it's not the same thing to shoot a rock against another rock than to shake a spider's web. What we're saying, they're shaking the spider webs. Okay, so we have a different interpretation of what they're seeing in there, and since they can't see that, they're making the assumption that they're looking at particles. And people confuse the assumptions with proofs. They say, oh, they've proven it. They haven't proven squat. They haven't seen it. They're just making an assumption that they're dealing with particles. Why? Because the particle is not a particle. That's why. Particle is a number for a mathematician. For a particle mathematician, all he's doing is having values. He's got values called energy, called mass, called charge. So he's accelerating a so-called charge, which is a concept. He's accelerating, if he accelerates an electron, he's accelerating 1.6 times 10 to the minus 19th coulombs. That's what he's accelerating. He's accelerating a value. How do you crash a number 5 against a number 4? Is there a way to do that? I mean, I've never seen that, but you know, maybe I'm wrong. Maybe you can crash numbers. But that's what they're doing. And so in order to put a number on their equation, they have to treat it as a unit, which is what the so-called particle is supposed to be. It's a value that they can put on an equation. That's all that matters to the mathematician. This notion that they're colliding corpuscles, that's what's wrong. That's not what the quantum mechanics are saying. The corpuscle died in the 19th century. As soon as we got into the first quarter of the 20th century, we got rid of the corpuscles. We replaced it with the word particle. And the word particle is extremely misleading, especially for people who are not familiar with quantum mechanics. What they're doing is not accelerating corpuscles, they're accelerating values. And until you get a grasp of that they're accelerating concepts, mathematical concepts, and they're squashing two concepts together. They're squashing love against intelligence. That's what these people are doing, or love against love. And people say, oh, they banged two particles. No, they banged love against love. They didn't bang two hearts. And people don't understand that. And until you really get a grasp of that these people are talking nonsense because they're talking about concepts, because they're trying to make sense of the description, not of a physical interpretation. Until you get a grasp of that, you know, all these pictures make no sense whatsoever. Because they're showing you a picture of something real. They say, look, we saw this in the chamber, in the gas that was in the chamber. So what was that trace? Well, we think it's a particle. Okay, what's a particle? Is it a little stone? Oh no, it's a value. It's a charge. It's a bundle of energy. It's a wave function. That's what they're telling you. And until you get a grasp, get a feel for that, you're lost, okay? It's very hard sometimes to tell people this. And here we have authority. I like to put authority because people unfortunately rely too much on authority, and here you have a little bit of authority. And it's from these gurus. And here we have the first one, Mr. Niels Bohr. He says, those who are not shocked when they first come across quantum theory cannot possibly have understood it. So if you think you understood quantum mechanics, it's because you haven't. Leo Susskind, a guy from Stanford, so-called mathematical physics of Stanford. He says, evolution didn't equip us to be able to visualize quantum mechanics. Evolution did this to us. And Mr. Feynman, who was Nobel Prize, 1965, I think I can safely say that nobody understands quantum mechanics. He's telling you in your face. And people continue to insist, no, they understand them. See, because we have all this technology, you wouldn't have a computer if it weren't for quantum mechanics. These guys are telling you in your face. They don't understand their own theory. In other words, they cannot explain the mechanism. Why? Because they're using concepts and because they're using the particle, and you can't produce pull with particles. So they will never be able to understand it under the quantum foundation, the assumptions of quantum mechanics. It says, do not keep asking yourself if you can possibly avoid it, but how can it be like that? Nobody knows how it can be like that with particles. The more you see how strangely nature behaves, the harder it is to make a model that explains how even the simplest phenomena actually work. So theoretical physics has given up on that. And of course, they'll never explain it with particles. You have to be a deranged loony after 10,000 years to insist on particles. We've been doing particles now ever since we can remember. Ever since civilization, people explained everything with particles, photons, and later on they went to electrons and atoms and so on. It was all particles. We cannot explain, especially action at a distance, pull with particles. You have to push behind it. You can't bring two things together by throwing stones. And they keep insisting because they can't get away from that, because all their values that they put in an equation are units. They're like particle, condensed convergence of whatevers. That's the problem. You can't explain it with that. And so, here you have a beam line, maybe at the Large Hadron Collider, and you have, are we accelerating particle? Are we accelerating little balls? Is that what's being accelerated there? Or, what do you think Thomas Aquinas would say? Because he might have a different interpretation. He might say, look, what you're really accelerating are angels, okay? Because it's got all these properties that we discussed the other day, okay? Gives us an introduction to the subject matter today. And, he might look at that and say, you're not accelerating particles. You're not accelerating real balls. What you're accelerating are angels. And he would be right, because essentially, the angels that we've been talking about have all the same properties as particles. They can be at two places at once. Many of particles can be at one place at the same time. They can be anywhere, so that means they can go from one place to another without going through the intermediate space. All those good properties that Mr. Thomas Aquinas attributed to angels, he wrote a treatise on us, right? Are the same thing that the quantum mechanics have applied to their particles. All these particles have magical superpowers because they can't see what's happening in that invisible world, and they will never be able to explain it with discrete particles. The particle hypothesis is what has to die. Anyone who's still insisting today on particles is a deranged loony. He needs to have his head examined, because after 10,000 years we should have figured out that you can't simulate Mother Nature's universe with particles. You simply can't, not with discrete particles. Okay, and people will twist and turn and say whatever they want to say. No, you can't. Okay, you got a problem if you insist on particles today. And yeah, we do rail against particles, and that's really one of the big problems. Okay, let's get on to Mr. St. Thomas Aquinas. And yeah, he essentially got his stuff from the Greeks, and specifically from Euclid, because Euclid is the guy who developed his theory of geometry. In other words, he wrote about it. And he's that fellow completely on the right over there in the middle. And the problem with that is, first, that Euclid was probably not the originator of all those theories. All these other fellows who came 300 years, 200 years, 100 years before him developed the theories or the notions of geometry. And what Euclid did was just compile them, put them together, and wrote his book, Elements, which survives to this day, and he got all the credit. Okay, now and here I've got Mr. Plato, and some of you know this, that on the door of his academia, okay, he had that inscription saying, "Let no one who in this case, let no one destitute of geometry enter my doors." And there's different ways of saying that, of how people have said that over the years. But essentially, geometry was around already. Everybody, from the Persians to the Greeks to the Egyptians, the Indians, all these people knew about geometry. They had to, because they had to measure the land, for one. They had to build houses. And they built big pyramids, I mean, the guy had to know a little bit about geometry, about triangles, about, all this other stuff. So, this stuff has been around for a long time. Euclid just kind of put it together, and it's commendable still, but again, he got it from all these other guys. What's the problem? And how did we get to Aquinas with this? Well, the issue is as follows. Euclid got it for sure, from Aristotle, who preceded him by probably 50 years, no more than 100 years. They were probably subsequent generations, one right after another. Euclid's from the 3rd century, and breaking into the 3rd century. He probably was born in the 4th century BC, and Aristotle, he died in the 4th century. So they probably never met, maybe. One guy died when the other guy was born, so to speak. But when Aristotle died, he left his school. And the school was the Lyceum in Athens. And lots of their students in this school, they wrote books and they wrote stuff, especially about geometry and so on. And they were interested in physics. That's the book that allegedly Aristotle wrote, and that survives to this day. And they were not interested so much in geometry because it was well known already. Euclid probably specialized in that, but these guys were interested in physics in general. They wanted to know how the universe works. And I think that's commendable, because that's the true nature of physics. You need to understand how Mother Nature runs her shop. That's the purpose of physics. And he who deviates from that is not a physicist. Okay? So the issue is that they were trying to explain how this universe works. Okay? And that's what Aristotle writes about in his 8 books called Physics. And so what did he talk about? Well, he brings in the particle, the point, and he brings in the line, okay, from geometry. And he's going to use those. He's going to use the point for location, and he's going to use the line specifically for continuity. For anything he wants to talk about continuous, he uses the line, okay? And the issue there is that, what do you mean continuous? Well, what are you talking about? Well, he's talking about time, talking about motion, talking about distance. Those are the things he's talking about. The number line, okay? These are the things where they're going to apply the words line and point. Okay, and so this is where the duality of these words comes in, because the line, you look and you say, what, that stick that's there, that's the line? Yeah, but see, that represents distance or displacement or time or the number line, the numbers. Okay, and how about the point? Well, the point, it's not really a dot, that's what's on the picture, but it represents a location. We had to put something in that location, we put the dot to mark it. So the issue is not that Aristotle or his disciples used it for for geometry. They wanted to figure out how the universe works, how Mother Nature runs her shop. For this, they had to talk about distance, about motion, about time. And of course, they brought in mathematics and they were talking about numbers, specifically the number line. And so this is where all these issues come in, okay? And what happens with Thomas Aquinas, he comes in 1,500 years later and he uses not only the Greeks, but some other people from about 700 years before him, like Boches and so on. And he uses their notions. And he tries to figure out, especially what concerns him, and that's whether the issue of omniscience, whether God is omniscient, and if he's omniscient, do we have free will? And so he talks a lot about in his theory about free will, and he also has to introduce what was popular in those days, which is angels. Okay, and so he started talking about the angels the other day, and this is what he puts up there. This is St. Thomas Aquinas. Okay, he's got all these questions that he's asking. Okay, and it turns out that these questions resemble pretty much what quantum mechanics has today. In fact, the issues are almost exactly alike. St. Thomas asks whether an angel is altogether incorporeal. And today we ask the same question in quantum, whether a particle is altogether incorporeal. Is it a concept? Is it an object? Are we talking about a corpuscle? What is a particle? And then St. Thomas will say, okay, an angel is composed of matter and form, yes or no? Do they exist in great numbers? Do they differ in species? Are there different kinds of angels? You know, does an angel have location? Is it in a place? Can an angel be at two places at once? And so on down the line. And you can see they match exactly with the issues that come up with quantum, 800 and 900 years later. And so these are the issues that we started talking about the other day. And the first two we covered, the altogether incorporeal and the matter and form. Let's look at a couple of the others today. It says, angels exist in great numbers. Do they exist in great numbers? Do particles exist in great numbers? Okay, this is the issue that we're going to start with, trying to answer those questions. So here's good old St. Thomas. And this is what he writes about this in general. I mean, I pulled the main points from his dissertation, whether the angels exist in great number. And he says, there have been various opinions with regard to the number of the separate substances. And he gets this from Aristotle. He harps a lot on what he calls the philosopher, okay? It is not true that the immaterial substances exist on account of the corporeal. Okay, so that means that, and he's talking about angels there, okay, the immaterial substances, that's the guys that are there between God and us. They're the mediators, okay, kind of like the particles at CERN and SLAC. The multiplication of the angels is not to be taken according to matter, nor according to bodies, but according to the divine wisdom devising the various orders of immaterial substances. Guess who that is? That's Mr. God, the man upstairs himself. And so continues, he says, in the angels, number is not that of discrete quantity. You can't count angels because, see, he switches back and forth between an angel, which you can imagine with feathers and ring on top of his head. That's an object. And the concept, the fact that angel represents a soul, the mind. So he goes back and forth with this and throughout his whole treatise. Okay, says so he says in the angels, number is not that of discrete quantity. Okay, they're continuous, so to speak, because he's again talking about concepts brought about by division of what is continuous, but that which is caused by distinction of forms. Okay, and so what's Bohr's answer to that? Here it is. Let's see if we can put it up here. He says the entire universe may well be infinite extent. These are his disciples. This doesn't come directly from Bohr, but it doesn't matter because they all have the same notion. The entire universe may well be infinite in extent. Time, these are different statements from people, okay, today. And these are all, you can say, formal notions that people have. these are PhDs that write these things. Time is infinite, but space is not. Another opinion. And then you'll see that article there came out of Popular Astronomy, but it was quoting, what was it? It was quoting some other article, but it doesn't matter. This comes from Popular Astronomy. It says, bearing its definition and nature constantly and unswervingly in mind, we may affirm with utmost confidence and positiveness that both space and time are truly infinite. So you have all these different opinions. It could be infinite. One is infinite, the other one is not. The other guy says, yeah, it's truly infinite. We have proved it. Okay. And what is an event? An event is, for general relativity, is the instantaneous physical situation or occurrence associated with a point in space-time. That famous word point. So we have, what is a point? Point is a dot, right? No, it's not. It's a location. What do you mean a location? It's a location where something happened. How can something happen at a point? How can you identify the word event, which is a verb, with a noun such as the dot or location or whatever? In other words, it's a static concept. Dot or location is a static concept. Event is a dynamic one. It's a verb. That's what an event is. We've turned event into a noun, but event is a verb. Event means something is happening. You can't have an event on a single frame of the movie. You need at least 2 frames of a movie to see an event. Okay? And what they've done is they condense that movie into a dot, into a location. Okay? That's what they've done. And then the question is, they say space-time is made out of all these events, all these dots that make up space-time. They talk about the quantization of space-time made out of dots. And then they tell you that space and time are infinite, therefore we have innumerable, infinite, incessant counting of dots, of points, of events. And if that's the case, well, no different than what Mr. Aquinas was saying. You don't have a fixed quantity of angels, of particles, of dots. You have an infinite quantity of them because space-time is infinite, supposedly. And again, they haven't decided whether it's infinite or not. They keep rolling around in circles whether space and time are infinite. And they'll be going around in circles for the next 100 years or until extinction. Okay. Here's the second issue that St. Thomas brings up, and that's whether the angels differ in species. Are there different kinds of angels? And I think there are, if you go into his mind, because he says, there are good angels and bad angels. You have these devils, and they're angels too, but they're dark angels. They're mean angels. They're red angels, maybe, I don't know. They come from the south, not from the north, okay? The good of the species preponderates over the good of the individual. So we're talking about a species versus the individual who comprises a species. Okay, because he's categorizing these things. He gets all these categories from Aristotle, by the way. Okay, hence it is much better for the species to be multiplied in the angels than for individuals to be multiplied in the one species. The perfection of the angelic nature calls for the multiplying of species, but not for the multiplying of individuals in one species. So he says, species, it'd be nice to have many. It's good for the universe. But within each species, it's not good that we have too many, that unlimited, within each group. Okay? That's his notion. What does Niels Bohr say and his people today regarding that? Well, what they produced is the standard model of quantum mechanics. And it looks something like that. These are the species, the types of particles. Okay? And so they're not infinite like St. Thomas's angels, okay? But it turns out that these are the primary ones. These particles, they become like, today they say there's like 200 particles at least. They have phonons, which are not included in there. They have tachyons. They created all these particles, solitons and so on. They create a lot of particles which they need to explain certain things. So they gave names to lots of particles that are not in the standard model. Okay, but so how many species are there? Well, quantum mechanics predicts, to use that term. They like that word, predicts. So I'll use the word predict that is so famous in mathematical physics. Quantum mechanics predicts a fundamental elementary particle. It predicts it. And you say, well, what, should we go to the lab and smash the particles and find out? No. We don't do experiments in science. Remember? Starting point today? We don't do experiments. We don't go to the lab. No, scientists don't go to the lab. That's for gophers. We send a technician and say, do this experiment for me. Bring me the results and I'm going to do the thinking. That's the way it works. The scientist is the guy that's upstairs, not the guy that's in the lab. Never does a scientist step in a lab. Okay? If he's in the lab, he's not a scientist. He's a gopher. So the question is, why do we need to run an experiment? No, we don't need to run any experiment. This is a conceptual issue, strictly conceptual. You smash particles, you get more particles. Now you smash those tinier particles, you get more particles. You can't continue smashing or dividing particles, as Mr. Democritus and Leucippus, his boss or teacher or instructor, said hundreds of years ago. You can't continue smashing them and arrive at nothing. You can smash a particle, cut it in half, in 4 pieces, in 10 pieces, any amount of time you want, any number of pieces you want. You'll never end up with nothing. You always, at the end, will end up with something. This is totally a conceptual issue. I don't need to go to the lab. I don't need to study mathematics or this. None. All I need to know is conceptualize it. I can't break something that has shape, and end up with something that doesn't have shape, with nothing. Okay? So if I cut and cut and cut and cut and cut, I will finally end up with something. Quantum mechanics predicts an ultimate elementary fundamental particle. Okay? And that's the particle that should be called the elementary fundamental particle that makes everything else. Assuming there's only one. We're just going to make that assumption. Could be 2, could be 3, fine. But different species, right? Like St. Thomas says here. But if we assume that there's one, there's got to be at least one, okay? We can't have none. We have to have at least one. If there's one, that's the one we're going to call the fundamental elementary particle. And we don't need to smash it, and we can't ask, well, what is it made out of? It can't be made out of anything because it's the elementary fundamental particle. That's why. That's the name. That's by definition. It's where the buck stops. Okay? Buck stops here. And so you can't continue smashing particles and always come up with more particles and say, I'm just going to name them and get my Nobel Prize. Doesn't work. You got to sit back, say there's got to be a fundamental particle that comprises everything else. If that's the case. But it has to be the case that at least there is one ultimate particle in the universe, because you can't keep chopping matter into pieces and arrive at absolutely nothing. So quantum mechanics, because of its assumptions, the particle assumptions, has to have a fundamental elementary particle. Okay? And so to answer Mr. St. Thomas, quantum mechanics' answer to that is there's only one particle, ultimately. At least one part. Okay? Maybe there's 2 or 3. I don't know. Fundamental particles are a little different for whatever reason one cannot imagine. But for sure there's at least one. And this is not a question of chopping them up. Okay? And I'm sure that if we had God's eyes and there were particles out there, which we say here there aren't, we should arrive at a single particle. And that particle, that's the one that received the name of fundamental particle. Okay, here's another comment from, this is another issue with the particle I showed the other day, where we have the particles come in from the void. Okay, so we have the virtual particle, which is a particle that comes into being when the mathematician needs it. And so the question is, are these particles Are these fundamental particles? Can we chop these up and come up with more virtual particles? Do they comprise the vacuum that forms a backdrop to matter? You know, they have these notions out there that they've created. Again, these are not particles, they're concepts, but they created all this because they have no explanation for how Mother Nature runs her shop. And so they had to create all this nonsense of virtual particles and quasi-particles that come in from the void, and then they go back into the void and comprise the void. They had to do all this. Okay, here we have another one from Mr. St. Thomas Aquinas, and he says the following. He says, whether an angel can be in several places at once certainly sounds a lot like quantum mechanics, doesn't it, right? We've had that notion of particles being in several places at once. It says, an angel's power and nature are finite, whereas the divine power and essence is infinite. Consequently, God is not merely present in some places, but is everywhere. Okay? Sounds a lot like the particles that we're going to see in a minute here. Okay? Some suppose the indivisibility of the angel to be like that of a point. Again, he's referring to location and not to the dot, because the dot is divisible. It's the location which is not divisible. So he says some suppose that that the angel was like a point, meaning location. Let's keep the words properly in their proper context, okay? Consequently, they thought that an angel could be only in a place which is a point. Again, location. He uses the word point, he uses the word, I don't know if he uses the word dot but he means location. He doesn't mean the geometric point, meaning the dot, okay, that is always put in at the start of geometry. But they were manifestly deceived because a point is something indivisible. Dot is divisible. What's not divisible is location, okay? Yet having its situation, meaning location. That's where he mentions essentially that he's talking about location when he says, yet having its situation. Whereas the angel is indivisible and beyond the genus of quantity and situation, meaning place, meaning location. Okay? So he says that the dot, the point, is not like an angel, because the point cannot be divided, but it has location. Meaning the location has location, whereas an angel can be, cannot be, is indivisible, cannot be divided, but an angel has no location. That's where it differs from the point. Okay, it is evident that to be in a place appertains quite differently to a body. Okay, to an angel and to God. A body is in a place in a circumscribed fashion, since it is measured by the place. An angel is not measured by the place. He is in one place in such a manner that he is not in another. So an angel apparently can only be in one place or another, right? But God is neither circumscriptively nor definitely there, because he is everywhere. And, what does good old Niels Bohr and his people say to that? Well, here it is. This is their answer from today. Quantum coherence from the Wikipedia. In Young's double slit experiment, electrons can be used in the place of light waves. He's talking about waves. Each electron's wave function goes through both slits in the slit experiment, for those of you who are familiar with it. What is he talking about? Well, fortunately, we have a little movie by Dr. Quantum, and he illustrates this. And here it is. Okay, what does Quantum show? Well, he shows that, you'll see it here in a minute when it starts again. The particle starts out from a gun, and in this case, it's an electron, and it's going to be shot out, okay, to the slits, but only one particle at a time. But it turns out the particle is at two places at once. It's at both slits simultaneously, and Dr. Quantum cannot figure it out. He said, what the hell? And here you can see it. The particle is at two places at once, okay? And then it kind of superimposes on itself. known as superposition, and that's how it's going to create the fringes on the wall. That's the explanation that quantum mechanics gives today. So can Niels Bohr and his disciples answer St. Thomas Aquinas regarding whether an angel can be at two places at once? Yeah, of course, there it is. It's called decoherence followed by superposition. So it's at two places, then it comes back together, and that's how it produces interference fringes. Constructive and destructive interference. That's the explanation we have today from quantum mechanics, because they insist on particles. And as long as they insist on particles, they're going to have to give you a nonsensical answer to the slit experiment. They say we cannot explain it otherwise, because if the photon is a particle or the electron is a particle, and it has to interfere, and to interfere it has to be two. The two have to somehow meet. But how did they meet if they had to go through these two slits? Well, it's very easy. We do it with a magic wand. We just say the particles at two places at once. And that's exactly what St. Thomas Aquinas said about his angels. Okay? We're going to continue on Wednesday with this. And just so you can see how Mr. Aquinas invented quantum mechanics, at least all the arguments that we have, all the explanations. And he justified each one. These guys don't even justify, and they say, look, we can't see in there. We don't know what we're staring at because it's all invisible. And we're going to insist on particles because there are particles, and we vouch for the particle. They can't live without their particles because particle represents a value, single value that they can put in an equation, so they will not be getting rid of the particle. And of course, when they try to give a physical interpretation to their equations, they have to use the particle, and they say, well, then we have to use the magic wand. We have to make the particle do things that we don't see in our real world. And one thing is for the particle to have different properties in the invisible quantum world of Mother Nature. We can deal with that. Well, we can't deal with some of the irrationality. A particle being at two places at once, virtual particles coming in from the void, from space, making up space, being the material of which space is made of, the ether, essentially. And then this particle disappears, and it's undetectable in our world. All they're doing is putting all this stuff beyond your comprehension. And they say, well, you got to study math to understand what we're saying. It's got nothing to do with math. It's a conceptual issue. We'll see you on Wednesday, and we're going to continue and hopefully finish up with Mr. Aquinas, if I don't get too many questions. We'll see you on Wednesday. Bye-bye.